as like before, if you just want to get practice, definitely pause the video, go read the problem, because otherwise it's going to be a little weird. You're going to be like, now what is she saying? So I'm going to kind of speed through it real fast. So pause this video and then pick up right back here. But if we look at number 26, it's talking about two buildings. A and B are built on the same horizontal plane, which just means they're on the same street. And from point P, which is on the closest edge of the top of building A, to building B, an observer finds that the closest point Q on the top of building B has an angle of depression. Okay, let me kind of slow down through that for just 1 second. You basically have two buildings, A and B. And what we don't know is, are they the same height, or is one larger or one smaller or shorter than the other? And if you read through that real quick, it says from point P, which is on the top of building A, an observer finds that building A to building B. Okay, observer finds that the closest point Q on the top of building B has an angle of depression. So if you're at point P, which is on the building A, and you're looking at point Q, which is on B, it has an angle of depression, obviously you have to be looking down. So if we call this building A right here, then we're going to call this one over here building B. Okay, and it says P is the point on the top of building A, and Q is the point on top of building B. Okay, and then it tells us that from point P, so looking from point P, we're going to give ourselves a horizontal reference, the angle of depression, so from the horizontal looking down, because it's always with respect to the horizontal, that the angle of depression right there is 28 degrees and 20 minutes. Okay, so writing that in there. All right, all of that was one long Q sentence, but now we can go to the next part. And it says, also from the point on the ground that is directly below P, the angle of elevation up to Q is observed to be 3830. Okay, so directly below P, now we're going to be looking up to Q, so the angle of elevation from the horizontal looking up, and that tells us that it's going to be 38 degrees and 30 minutes. All right, and the last part says if building B is known to be 192 feet tall, and then we want to know the height of building A. So this is our big question mark. Okay, well, let's look and see what we can do for this problem. Let's see if we can utilize the fact that the building B is 192. If I come over here to building A and I chop it into two equal parts, well, I know that this height from here, which is equal to the height of building B, if I kind of make it a little bit better, then that's 192. Hold on. And then all we have to do then after that is just find this upper portion up here. We can call that, I don't know, let's say that's X. Okay. Well, let's make ourselves a right triangle through here. That if I know, let's see, if I know this angle right here, which that angle 2820, do you see how it's also symmetric with this angle right there? That's just if you take two parallel lines, and if you take two lines and you bisect it, then the angle that's coming in from right here is symmetric with that angle, which is symmetric with that one, which is symmetric with that. It's all those rules of geometry you learned back in, gosh, what was that, 7th grade or something like that? Okay, so those are things that we know. So if that is 2820, then this right here is also 2820. Okay, well, that's something that we definitely know. What else? Let's see what else we can use. If I come down here below to this big right triangle right here, I know that if I can find this side right here, which is the distance from here to here, then that side right there is also going to be that side up there. And that can really help us find our part whenever, because really our goal is just to get X, then we can combine that with 192 to get our answer. All right, so let's see if we can get Y. Okay, so in this right triangle right here, we have an angle. We know its side that's opposite it, and we want to find the side that's adjacent. So what involves an angle opposite and adjacent? It has nothing to do with the hypotenuse. Well, it's tangent again. So the tangent of 38 degrees in 30 minutes is going to be the side opposite, so 192 over the side adjacent, y. And remember, anytime our variable's in the denominator and we want a quick solve, just swap those two around. So y is, and remember, that only works for denominator, by the way, not the numerator. So y is equal to 192 over the tangent of 38 degrees in 30 minutes. Okay, and if we plug that into our calculator, you know, basically 38 You remember when we type that in, you can write it as 38 plus, I guess we really don't need the degrees, but what you can do is write it as 38 plus, and it's always that angle divided by 60, remember, or the minutes divided by 60, okay? But when we type that in, you'll get roughly 241.377, and right now it's feet. Obviously, we don't want to work with that, so let's just round it real quick. So we're going to call it 241 feet. Okay, so that's that part. Let's go in here and see if we can finish up the rest of this. So if that whole distance down here along the bottom is 241, well, I know this angle right here. So, and I want to find x sitting over here. So with respect to that angle, I don't need to know this hypotenuse whatsoever. So it looks like we're going to go with tangent again. So the tangent of an angle, which is 28 degrees and 20 minutes, it's going to be the side opposite it, which is x, over the side adjacent, which was y. I just now found out what y was. So we can write this as tangent of 28 degrees and 20 minutes is equal to x over 241. And then just to get x by itself, let's multiply both sides by 241. So when we just type that in our calculators real quick, we'll get an x value of 129.94. And then like before, if we round, we can call this basically 130 feet. All right, now was that our answer? Not so much, because the answer asked for the whole total height of building A. So building A was 192 plus x. So building A is 192 plus 130. So the height of building A equals 322 feet. And there's our overall answer. So we basically had to use two right triangles in order to solve for this one. But in both cases, you just use your properties of SOHCAHTOA, and we used a little bit of geometry in there with realizing two angles that were symmetric with each other. Let's try this again with example 4.